Okay, so what I want to do in this video is I want to find the following trigonometric values, okay? These are half-angle identities, so you will have to know what they are, and since I haven't done these in a while, I kind of forgot how, the, the, I forgot the formulas, but, so basically, we have that sine of theta is equal to 8 over 17, right? So for sine of theta over 2, it depends on where the quadrant or what is it called? It depends on where on what quadrant the ratio is in. So basically the trigonometric value, it depends on what quadrant it is. Sine of theta over 2 is known as plus or minus the square root of 1 minus cosine theta, all divided by 2, okay? So, knowing that we have this, and knowing that, so since we have, basically we have the following function. So we have the following trigonometric value, that sine of theta is equal to 8 over 17. Since top and bottom are positive, it's very clear that it's in quadrant 1, because if you think about it, here's your radius, and then this is the right triangle. So then you would say that this, and here's our theta, you would say that this is 8, it's opposite over hypotenuse. This is 8 over 17, right? And notice that this is x, this is y, and this is our hypotenuse, okay? Or you can also say r squared, or r, the radius. But we know that sine of theta equals 8 over 17. Now, you can find the rest of, or you can find cosine theta by doing the Pythagorean theorem. So you have, so if we kind of draw the what is it called, the right triangle separately, and we put, and it doesn't have to be perfect, by the way, and then we put 8, or sorry, we put 8 right here, x right here, and 17 over here. We can say that because this is, the following is true, we can say a squared plus b squared equals c squared, right? So this is our a, this would be our b, and if I color code, this is 8, this one would be x, and then I can do my c squared as another color, so this one would be 17. So I can say the following: a squared plus x squared equals 17 squared, right? Okay. So this would be 8 squared plus x squared equals 17 squared. So basically, 17 is our c squared, basically, or sorry, our c value. And we want to solve for our missing side. So we would have 64 plus x squared is equal to, I believe it's 289. We would then subtract 64 on both sides, and you would get x squared equals 225. And then what you would do, because it is, since we are solving for x here, we would want to say that it is the positive side, the positive measurement, or the positive, x-axis. So basically we would say, we would take the square root of both sides. This would be x equals, and first you would say plus or minus, and if you take the square root of 225, I think it is, it's 15. However, because this is a, so basically because this is a, because it's in the first quadrant, so basically because it is in the first quadrant, and because opposite over hypotenuse they're both positive, that means that x is positive, so we would say that x is 15. And then, so we have the following right triangle, you would say, that this is 8, this is x, or sorry, this is 15, and then this is 17 over here. Now, to do sine of theta over 2, and when I say that, I mean sine of theta, sine of the quantity theta divided by 2. So the half angle. And the way to do that is we have to take the square root. So we would say this is sine of theta over 2 equals the square root of 1 minus the cosine theta over 2. And it's positive because you see it's in the positive, because cosine theta in the first quadrant is positive. That is because x is positive. X equals cosine theta. Okay, and y is sine theta. Always remember that. So, we would then say that, sine of theta over 2, and we would go ahead and do the cosine theta. So cosine theta would be, this is our angle theta, it would be opposite over hypotenuse, which would be, or sorry, adjacent over hypotenuse, excuse me, which would be 15 over 17, because cosine theta, of course, is adjacent over hypotenuse. This is adjacent, this is hypotenuse, okay? So then, we would say that this is equal to the square root of 1 minus, and we would go ahead and plug this in for cosine theta. So we would say 15 over 17 all divided by 2. So it'd be the square root of 1 minus 15 over 17 all divided by 2. And the 1, so we have sine of theta over 2 equals 17 over 17 minus 15 over 17 all divided by 2, and you take the square root of all of this. This is equal to the square root of 2 over 17 divided by 2. This is equal to the square root of 2 over 17 times 1/2. And if we cross multiply, or if we cancel out the terms basically here, we would have that this is equal to the square root of 1 over 17. And you can do just, because this is in the, because sine of theta is in the positive y direction, since it's in the first quadrant, and sine of theta is y, so basically because sine of theta equals y and sine of theta is greater than 0 in the first quadrant, we can say that this is equal to 1 over the square root of 17. You can rationalize this and say that this is equal to the square root of 17 over 17. How I did this was I just basically multiplied by the square root, and I got square root of 17 over 17, okay? So this would be sine of theta over 2. Now, to do cosine theta over 2, if we do cosine theta over 2, let me just write it down. That one's a little bit more different. So let's see. If I look up the formula for cosine theta over 2, it's almost the same thing as the first one, except you are doing, so the cosine theta over 2 is plus or minus the square root of 1 plus cosine theta, all divided by 2, okay? And, so, again, if we look at our right triangle, we can say that, so basically we have theta here, and then we have, what is it? It would be, so it's 8, 15, and 17. So we have 8 here, 15 here, and 17 over here. Cosine theta is equal to, and it's a lot easier because now we have all of our 3 values on the 3 sides of the triangle. Okay, so we would say cosine of theta divided by 2, or sorry, no, cosine of theta, excuse me, because we want to first know what cosine theta is, since, you know, it's asking us here what is cosine of theta. And so we would say that cosine theta is adjacent over hypotenuse. And so then you would say it would be 8 over 17. Or sorry, 15 over 17. Sorry guys, I keep messing up. It'd be 15 over 17, so then you would say that cosine of theta over 2 is equal to, and since cosine is in the positive x direction, because, you know, we have an 8, that's, you know, that's basically, we have an 8 right here, a 15 over here, and a 17 over here. If you draw it in the Cartesian plane, you would get positive 15, positive 8, and then, you know, 17 over here. So that's how you would know they're positive. Now, so cosine of theta is 15 over 17, so we have plus or minus the square roots, and it's the positive square roots because, again, it's cosine of theta, you know, basically cosine of theta over 2. Since we know that cosine of theta is positive, we would do the positive square root. So we would have 1 plus the quantity 15 over 17 all over 2. And now this would be, it would be 17 over 17 plus 15 over 17 all divided by 2, and then you take the square root of that. And then you would say this is equal to, it would be, I believe 32 over 17 all divided by 2, and then you would take the square root of that. And then you would go ahead and say this is equal to the square root of 32 over 17 times 1/2, which is equal to the square root of 32 over 34. Now, you can simplify that, and you can say that this is equal to the square root of 16 over 17. This is just the square root of 16 over the square root of 17, and the square root of 16 is 4. So then you would have 4 divided by the square root of 17. Now again, you can rationalize. I know some professors, they don't require you to do this, and others do. So the way I would do it again is I would just say times the square root of 17. Whatever square root you have on the bottom, just multiply it on top and bottom to rationalize. So then cosine theta over 2 equals 4 square root 17 over 17. Okay, now we're going to do tan theta over 2. This is the last part of this video. So tan theta over 2 is a little bit more different than the first two, okay? Tan theta over 2 equals plus or minus the square root of 1 minus the cosine theta over 1 plus cosine theta. Okay? So, again, we know what cosine theta is. Cosine theta is 15 over 17. So we just have to go ahead and plug that in. Once you know, basically once you know, like, most of your trig functions that they ask you for these problems, like especially for cosine theta, and yeah, especially for cosine theta, like literally for all of these 3 problems, when you're finding these 3 things, the only thing that you probably need to know is cosine theta, and you just have to plug it into the formula. So cosine theta, again, since it's the same triangle, it's 15 over 17. So we would say that, and also, since it's in quadrant 1, because, you know, we have positive, the x value is positive, the y value is positive, so the tan theta is y over x, so we have 15 over 17, meaning that, you know, y is greater than 0, x is greater than 0. That means that sine theta is greater than 0, cosine theta is greater than 0. So it's going to be positive. And since, you know, since we're doing 1 minus and 1 plus and stuff, since we're doing cosine theta, it's going to be the positive square root. So we're going to say the square root of 1 minus 15 over 17 divided by 1 plus 15 over 17. This is equal to the square root of 17 over 17 minus 15 over 17 divided by 17 over 17 plus 15 over 17. This would be 2 over 17, so 2 over 17, square root of 2 over 17 divided by the square root of, or basically 32 over 17. This would be the square root of, and you can always, if you don't remember how to divide fractions, you can always rewrite it like this. Oops, sorry guys, hold on. Sorry guys, my phone was ringing. So like I was saying, you can do divided by 32 over 17. This would just be the square root of 2 over 17 times 17 over 32. This would cancel out. You would just get the square root of 2 over 32. Again, you can go ahead and simplify this fraction by reducing it. So this would be the square root of 1 over 16. Now, you can say the square root of 1 over the square root of 16. This is just 1/4. And it's positive because, again, we're taking the positive square root. So, tan of theta over 2 equals 1/4. Okay? And that is how you do, for all of these, that is how you do the trigonometric values for all of these. So thank you so much for watching, guys. If you guys have any questions, please let me know. Other than that, I hope this video helps everyone, and I hope that I hope that this made it easier for everyone. Please don't forget to like, comment, and or subscribe, and I will see you guys in the next video. Bye guys.